We're now looking at some more examples based on exponential. Sketch. Hello.
I'm saying I have a question. You said, is it always that the graph will have to cut from the point 0,1?
0,1, 0,1. Yes, but not for all graphs. So wait and see this example. Sketch f of x is equal to 1 plus e to the power x. So we have what we call a vertical shift. Just like we had shifts on trig, so we have a vertical shift of 1. What this means is that we don't need a table to get the values, since we have already known that the graph of e to the power x looks like this, where this is 1. Okay, now this graph we have done here is the graph e to the power x. Now we are adding a 1 to this graph. So the first thing to move is the asymptote, because we know the x-axis is the asymptote. And it is a line y is equal to 0. So the first thing to move is the asymptote. We'll add the 1 to 0, meaning that our graph f of x will be, first, the intercept 1, you add a 1. So you know the intercept now is going to be 2. The asymptote 0, you add the 1. It's going to be 1. And so we're saying the asymptote now has become 1. And then our state will come back. This is the graph f of x is equal to 1 plus e to the power x. Hello.
So you mean you just move one step ahead of the,
because we are adding 1
value
to the full graph, yes.
So
And we call that standing 1 the vertical shift. Hello?
How has the dots, as in those dots that you have put there on the line on 1, helped us draw the curve?
Because this is telling us that you know we said this function will never be 0, is it?
Yes.
So if this function will never be 0, then we'll never have 1 as f of x. It will always be 1 plus something. So we are saying that this one is just saying we'll never have it.
So it's showing where we'll curve from. We'll curve from 1.
It is an asymptote.
Okay.
Representing the x-axis for this graph.
So, sir,
Like
if that was 2.
If f of x was equal to 2 plus e to the power x, our graph would then be this, the dots would go to 2. So 2 plus 1, 3. And so our graph would come here. Someone was saying something.
So 1 plus 70e to the power x will still look like that.
Yes. We don't care how big the number is, because we know 70 to the power 0 is 1.
So, sir, if the E was alone, the graph would have passed at 1.
Yeah. Yes.
Okay.
Sir,
Mm-hmm.
what's the number where the graph is passing there? Is it 3 or 4?
It's 3.
Why 3? Not to be 4. Isn't it the graph is shifting 2 units?
2 units. Yes. But which graph? Not this one, but this one. E to the power x is shifting 2 units up. And so what was the x-axis has become 2. The asymptote. And then from the asymptote, you move 1 step.
So I don't understand as well.
Yeah.
Because it will be
I'm not-
like, yes, what she's saying.
Mhm.
The same thing she's saying. So I think that's what I'm also thinking, because here we're adding 2. If e to the power x is 1,
What is 2 plus 1?
e to the power 0 is 1.
Mhm. What is 2 plus 1?
Okay, so
Sir,
Hello?
sir, make me understand. Like for
Uh-huh.
this one, the first one, we had 1, the vertical shift was 1. That's why we made 1 to be the asymptote and shift 1 unit upwards. Now this one, the first point was 2. Now why are we shifting 1 unit upward?
Look, what we did here is we shifted the 0, which was the x-axis, 1 unit up. And so it became 1. Then we are saying e to the power 0 is 1. So what is 1 plus 1? 2. That's why it crosses at 2. You come to example 2. F of x is equal to 2 plus e to the power x. You shift the x to 2, the asymptote. Now, what is 2 plus e to the power 0? What is 2 plus e to the power 0? E to the power 0 is 1. So what is 2 plus 1? 3.
It's 3.
So it will cross at 3.
Sir, also me as a,
Thank you.
I want to
Mhm.
E on 2. Why is it that the asymptote is 2? Why isn't it supposed to be 1?
So why should it be 1?
Then you move 2 steps ahead.
The 2, this number that stands alone here, is how far you move from the x-axis. Is that okay?
No, make me
So,
understand.
so for the asymptote is 0.
so I don't understand the question. What has she asked?
She's asking that why have we moved 2 steps from x and not 1 step and then move 2 steps from the asymptote?
Oh, all right.
So the answer is we move 2 steps from the x-axis, looking for the asymptote. Since we are saying that this number here will never be 0. Okay, so since this number will never be 0, we'll always be getting 2 plus some number, meaning the least number is not 2. And so 2 becomes the asymptote that will never obtain. F of x will never be 2. It will always be 2 plus something. So we say the asymptote is 2. Now, where will this graph cross the y-axis? We know on this line, the y-axis, we have x0 here. So you go back in the function and substitute what is f of 0. F of 0 will be 2 plus e to the power 0. But e to the power 0 is 1. So we get 3. So from 2, we move to 3. And 3 will be the intercept.
Sir,
Hello?
sir, you've left me at example 1. I don't know what's happening.
What about example 2?
I got lost just there on the first example.
All right. So example 1, we have 2 illustrations there. The first thing we have is this thing in the box. We're able to sketch this function. We sketched it in the first session. We said e to the power x is just the same as 2 to the power x. It's a graph that passes through at 1 and having that shape. Now we want to add 1. This function f of x is adding 1 to all the points of e to the power x. The visible numbers that we have are 0 and 1, where 0 is treated as the asymptote. We made mention that this graph will never touch 0, to never touch the x-axis. So what happens when we add 1 to every point of e to the power x? 0 plus 1 will give us a 1. So the asymptote ceases to be 0, it now becomes 1. What is 1 plus 1? 1 plus 1 is 2. So the intercept has become 2. And then we bring the same shape. And that's how we sketch 1.
So
Sir, you're saying that e to the power x is equal to 2 to the power x. Is it always equal to 2 to the power x, so it can also be equal to other numbers like maybe 3 to the power x?
So we are saying they have the same shape as 2 to the power x, as 4 to the power x, as 100 to the power x, any number, for as long as it's a positive constant.
Okay, so you use the same graph that you used, except now you're going to be adding 1
Yes,
to all the numbers that you had found.
exactly.
And then on the asymptotes, I'm not very clear.
Okay, there was another question.
and I wanted to find out, so if you had to subtract, let's say 1 minus e to the power x, does it mean the asymptote changes from 1 to -1, from 0 to -1?
Yes.
All right, thank you.
There are 2 answers here. Which one?
What function has she mentioned? I didn't get her.
1 minus e power x. So I
Oh,
said
yes.
the asymptote.
Title logarithms
Yes,
and
it will
exponential
change
functions.
it will shift to -1.
Uh,
Since at first it won't.
I think it will
Intercept.
change the topic.
Intercept. The intercept will
Sir.
change.
Hello.
You said you're supposed to do logs after this, after graphing.
Yeah, except that we have become slow here. So we'll follow the pace of the understanding.
Sir, the 1 minus e to the power x, won't it be 0?
We haven't reached there. First, let's move. Are we okay with this page?
Yes, sir.
It's very okay.
Yeah,
Uh-huh.
I'm still waiting.
For the asymptote, so for the asymptote, what we are calling the asymptote is 0 for the original function, e to the power x or 2 to the power x. If there is n number added, that number becomes the asymptote automatically. So when we added 1, 1 became the asymptote here. When we added 2, 2 became the asymptote. So n number that is being added becomes the asymptote.
Okay, thank you,
So the
sir.
asymptote will be 1 in 1 minus e to the power x.
Y is equal to 1 minus e to the power x. We know that the graph of, if this is -1, we know that this guy is the graph of what? Y is equal to -e to the power x, is it? Look at the shapes. Okay, so you have seen that is the graph. If you add the 1 to this graph, what will happen? The asymptote will move from 0 to 1. So 1 will become the asymptote. So okay, let me put it separate here. 1 will become the asymptote. And what happens when x is 0? When x is 0, we get e to the power 0 is 1. So y becomes 0. So we have the 0 here as our intercept. So the graph will be of this nature. This is 1. And the graph is y is equal to 1 minus e to the power x. So the key thing is knowing the shape of each family. So forget about this number first for you to know the shape. You forget about 1 first. What is the shape of y is equal to -e to the power x? After you identify that this is the shape, you come back now and add 1 to every important point. So when you have 2 important points for these graphs, the intercept, I mean the asymptote and the intercept. So if the line that is not being touched is 0, you add 1 to 0. You know now that the line that you won't touch will be 1. And then from -1, the intercept, you add 1, you get 0. So 0 becomes the intercept.
You're saying that you add the number that is there to 0 to get asymptote.
To get the asymptote, yes. Get the asymptote, yes.
Okay. What if it was negative minus the power x? So that asymptote would have been -1, right?
The asymptote will always be that number being added.
It was negative. Yes, -1 minus e to the power x.
So if you're adding,
so the asymptote will
y is equal to -1 minus e to the power -x, is it? Or you're talking about, yes. So the asymptote will be -1. So it will be -1. And then the intercept will be -2. So it will come out like that.
Sir,
Hello.
sir, you said you just draw, like you just follow how the graph is supposed to be.
Yes.
Now, how do you follow without knowing the coordinates exactly? And then can you please,
So look at
can
look at those 4 graphs that we have in the first session. Those are families that will follow. So in every question that you see, if there is anything added, the first thing you do is to ignore whatever is added and get to know the family so that you can know the shape that you're dealing with. To that shape, you add whatever is being added.
Oh, okay, sir. But sir, can you please show me how you're adding -1 to now, like the different coordinates? Because I'm not seeing.
So this graph is not about the x coordinates, it's about the y coordinates. So no x coordinate will show here. What is of significance is the y coordinate. So for whatever x coordinates that you have, you can have 20 of them. They won't help you much. The only coordinates that matters is 0. What happens when x is 0? You get the intercept. The next thing you do is, after having the intercept and knowing the family, then you look at what number has been added. The number added becomes your asymptote. You're done. So you won't see visible additions based on the x values. You will see visible additions based on the y values.
So repeat on finding the asymptote.
The constant added becomes your asymptote. That's all. Let me give you another example.
Sir, wait a minute. Yeah, network it was, but yeah, on question 3, like, why are we putting 2 there? Like the dotted line you have indicated 2, then you have passed through 0, 0. I don't know.
This is 1.
I was locked out.
So remember, on this page, we made mention that the shift will always be the asymptote line. So our shift here is 1. So 1 will be the asymptote line. Then you find the y-intercept. How do you find the y-intercept? You either substitute where there is x, you substitute 0. We know you've been doing this for all functions since topic 2. How do you find the y-intercept? You substitute x is equal to 0. You find the y-intercept. For all the polynomials, how do you find the y-intercept? When x is 0. So you do the same in this family.
So I can't see point.
Hello?
I can't see your screen.
Who else can see the screen?
Okay, so I found it.
Okay. So let me give you another example so that you have less questions. 5. sketch f of x is equal to -2 plus e to the power -x. The first thing you do, you want to answer this question. The first thing you do is you remind yourself, what family of shape am I dealing with? This shape. Okay. So from that shape, what next? I have a number being added. Okay, so my f of x is going to be, instead of me dealing with the x-axis as the as the asymptote, my asymptote now will be -2. So you go to -2 and draw the asymptote. That's the first thing that you do after recording the family and the shape of that family. Then you introduce -2 now as your asymptote. The family remains the same. Okay, so you notice that if you get f of 0, you have -2 plus e to the power -0. This is the same as -2 plus 1. -2 plus 1 is -1. So at -1, the function will cross the y-axis. Yes, the y-axis. So the graph is going to be same behavior, but cross here and go up. So what is this? If you're asked to state all the intercept, you must be ready to do so. So you know that happens only when this guy is +2, and it's possible. For some powers, maybe it can be +2. So you say -2 plus e to the power -x is equal to 0. Take this to the other side. You have e to the power -x is equal to 2. What next? You introduce. So before we talk about the next, so you just leave it here. I realize that I haven't taught you the logs. So suspend it now. So that's how your sketch will come out. Why do we put, so before we talk about e to the power 0, what's the purpose of f of 0? It is f of 0 that gives us the y-intercept for every function. So keep this in mind. For every function, be it a normal function, the polynomial function, the trig function, any kind of functions, it crosses the y-axis when x is equal to 0. It crosses the x-axis when y is equal to 0. So the purpose why we are solving for f of 0 is that we are looking for the y-intercept. So f of 0 means where there is x, take 0. That's why we are seeing e to the power -0, because there was x here. So only two things to note for you to be able to sketch these functions. One is that this number added here becomes the new asymptote. Two is that when you substitute 0 where there is x, you get the y-intercept. And then you're able to sketch your graph for as long as you remember the family. The first session had the families of exponential graphs.
So what method do you use? What do you for you to recall these families, like the 4 families that you have talked about, where you said e to the will be like this, like the way we do for soccer. Remember, students.
There's no such a pattern here that will help you remember. That is no.
No witchcraft.
But in any case, you guys know that for you to go in an exam, there are things for every course. There are things that you must know, that you keep in your memory for that exam. And those things are the ones that you use to generalize for any question that they bring. For example, sine 45. I don't really have to drive it every time I'm told sine 45. Those are things that we should know. So the same thing here, the families. But you're given a clue. In case you forget, and you are seeing y is equal to e to the power x, how do you remember in case you have forgotten? I've said use a simple number. Use 2 to the power x. Pick just 3 values of x. Pick -2, pick 0, pick 2, or -1, 0, 1. The shape will come. You will see the shape. Once you see the shape, forget about these numbers. Just pick the shape and begin to apply the principles attached to the question. So it's time out, but the next class is at 16:40. So if you can give me 15 minutes more.
That's been moved to 18.
18 hours.
Move to 18 hours.
Yes,
Yes.
sir.
Okay, give me more session then.
Yes, why?
We just
Okay. Now some of us to travel from home.
My head will burst.
And at night
Sir, these graphs, is it okay to just draw the dotted line for the normal one? Then I shift like that one without showing my work, like calculating y what is equal to what, just drawing like that.
It's very much okay for as long as you label. Okay, we'll call it a day.
Okay, thank you.
We'll move at the speed next time.
Thank
Sir,
you,
wait,
sir.
sir.
Hello.
So in an exam, in the case where you're giving the asymptote and the intercept, that's it.
I didn't get your question.
I mean, in a case where you're given the exponential, the e in an exam, it's okay to just show the asymptote and the intercept. That's it.
That's all.
All right, thank you.
Yeah.
Sir,
Hello.
hello. Can you ask him for the first session? We're being looked out. Network was bad here.
Okay, I'll send it.
All right, right.
We're talking about